All right. My name is Albert Engel. I teach engineering here at South Seattle College. We're over in West Seattle College. Um, and I teach for our engineering transfer program at South. One quick little housekeeping tip here. If you're interested, if you like captions, if you're using a PC, you can look at the bottom, look for the show captions button. It might be hidden under the more button, and you can turn on captions there as we go to help you if that will be helpful to you. All right. As I said before, if you have any questions, throw them in the chat. I'll be monitoring that if you're and answering those as we go. But we'll also have a little bit of time here at the end. First, I want to do a little introduction on who I am, what my background is, because there's lots of different types of engineering. We'll talk about what engineering transfer is. How is it different than getting a 2-year engineering technology degree? I'll talk a little bit about South Seattle College's STEM community. That's science, technology, engineering, and math. What sort of unique opportunities we have at South Seattle College in particular. I'll talk a little bit about our engineering pathway, what sort of classes that you're going to take, and then a little bit into our program, what sort of courses that you'll take, and some of the projects that we work on in that. And then talk a little bit about what engineering jobs look like in and around Seattle. What sort of salary you can expect and what sort of industries you'll work for. All right. So a little bit about myself. My name is Albert Engel. I actually started out my educational career at a community college too, in Texas, Tarrant County Community College. After that, I transferred to Vanderbilt University and I got a bachelor's degree in civil engineering. Civil engineering is all of the structures and systems that keep our civilization going. So that was kind of my background. Then I went to graduate school at Stanford. I got a master's degree in structural engineering and geomechanics, geo being earth, mechanics being the study of motion. So studying earth movements, specifically earthquakes. So that's kind of where that was the thing that I really wanted to do, was learn how to design things to withstand earthquakes and work on sky rises. That was been my dream. And then I did that for 2 years. I worked as a structural engineer. I designed lots of cool buildings. This is one of the buildings that you might have seen here in Seattle. If you've ever taken the ferry, you might have walked across this pedestrian bridge over here and seen the Coleman Tower over there. Another project that I worked on, a little bit taller, bigger residential high rise, is 52 stories, and this is in San Francisco. You can see the San Francisco Bay Bridge behind it. That's one of the cooler, taller building projects that I worked on. But I decided my favorite part about engineering was actually communicating and teaching people how to do engineering. And more and more I started doing that, I realized that's what I wanted to do. So that's how I ended up teaching here at South. And it's been fantastic ever since. What do I do here in engineering transfer? So engineering transfer, our program is geared to help students become design engineers. We'll talk about the difference. What does that mean in a sec? But the following fields, these are kind of the big majors that students will end up in. Civil, that's kind of my background. Environmental, which is kind of a little bit of an offshoot that now stands on its own. What is the impact of our structures and systems on the environment? What is mechanical engineering? And kind of subset to that is aerospace. So, how do we design the mechanical devices, the vehicles, and all of that gets us around, and all of the mechanical devices that we use in day-to-day life. And the last but not least is electrical, and kind of attached to that is computer engineering, which is kind of that middle ground between electrical, which is all hardware, and software software. Right in the middle is that kind of computer engineering piece. All right. If you're unsure about which discipline or major, and you're kind of on the fence and you still don't know what those are, I really encourage students to take our intro to engineering class, Engineering 110. It'll help you figure out what sort of industries and jobs all of these interface with. You know, if I want to work for Boeing, what type of degree do I need to get? If I want to work in electrical engineering, what sort of industries could I end up in? Those are some of those options that you'll learn about in that intro to engineering class. You'll also learn about some professional skills that can help you in the industry. You'll develop your course plan because for engineering education, there's a lot of prereqs and you got to take classes in the right order. So this will help you build a transfer plan that will be really successful. And then you'll also get to do some cool projects around real engineering problems. All right. So what do I mean when I talk about transfer? All of our design engineering jobs require a 4-year bachelor's degree. So what that usually means is students that will be looking for, after they complete their 2 years, you'll be looking for a program to complete your junior and senior level coursework. So that's where you get really specialized classes. A lot of our students end up in the UW system, either at UW Seattle, Tacoma, or Bothell. We've also seen students transfer to Seattle U. A lot of our students end up Seattle U or Seattle Pacific University on scholarship. And then we also have some students that go a little bit farther afield to Washington State. We've also had some students, of course, leave Washington altogether, but those are kind of our big transfer schools that we see a lot of our students go to. All right, I promised to talk about the difference between design and technology. So engineering designers are more on the theoretical level. They're less hands-on. That doesn't mean that you're not doing cool stuff. That means that you're doing the really high level, asking the hard questions about how these things work. How do people interface with them? All of those really important design questions you're addressing with mathematical models, with physics models to solve those problems. You then create plans and designs that your fabricators will use to build that thing. And then your coursework will really focus on those advanced modeling math. You'll take a little bit more advanced math courses and more theory on how this stuff works. Engineering technologists is different in the fact that it's a lot more hands-on. It's less about the how, about the why and the what are we doing, and more about the how do we get it done, right? And that's more of like prototypes, creating hand prototypes, doing drafting. They also take more classes on actual manufacturing, so you're learning how to do these things with your hands, so you can help engineering designers make that leap from the paper to a physical object. And our program at South focuses on designing, so you can get high level and you can really solve some pretty cool complex problems using the skills that we teach you. All right, so where is our engineering transfer program offered? I can speak only for South Seattle College, but we offer similar programs at Central and North, but it's a little bit different. Our course offerings are a little bit different, and some of the STEM opportunities might be a little bit different. So I can't speak directly to their programs, but I can speak directly about South Seattle College. So I'm going to give you a little bit of flavor about what South Seattle College has to offer. First part of that is really about our STEM community, right? Our engineering is just one piece of our science, technology, engineering, and math community at South. And here are some cool opportunities. Rocket Club, our Makerspace program, the RST Scholarship, and STEM Core are some opportunities that I want to get into a little bit. First one's our Rocket Club. Our Rocket Club does both model rocketry, and also we get to do high-powered rockets, which is really fantastic. So you can see kind of the size and scale. That's me over here with some students and our astronomy instructor prepping a rocket for launch. So we go high-powered rockets. These are rockets that we're going out to Eastern Washington, away from airports to launch. We have to drive pretty far out into Eastern Washington so we can launch these safely away from airplanes. And we also do local launches on campus and support launches, do outreach for local scout troops, and also for the Museum of Flight. summer programs. So we get to work with students and kind of give them those sorts of cool science STEM experiences that help inspire the next generation of STEM students, which is really fun. Another really cool opportunity at South is our makerspace. If you have, if you want to learn design, prototyping skills, and build skills, this is a great place for you. We have options for a lot of high tech manufacturing, but also some low tech fabrication skills. 3D printing, laser cutting. We have a vinyl cutter if you want to make stickers or decals. We also have electronics and soldering equipment to create and fabricate custom electronics projects. If you want to learn more about that, especially for our electrical engineers, this is a great resource. We have a lot of students that are also interested in miniatures and props, and then also a community of students that are working in fiber arts. If you want to, learn how to knit or crochet or make lace, we have a lot of students doing those sorts of things too. It's a great place to practice design and prototyping because design is a complicated process. So working on your design skills in your personal projects can help translate into bigger, more complicated projects with more coordination. So it's a really great way to kind of stretch those design muscles. Here's some pictures of from our makerspace. One of the fun projects that we did with our students was fabricate our own Prusa 3D printers. And then we also did some laser cutting. Here's an example of some laser cutting that we did for some of our projects. I'll show you some design that students have made for our engineering classes using the 3D printers and the laser cutters a little bit later. If you have any questions, please throw them in the chat. I haven't seen any so far, but if you have any questions, please at any point jump right in. All right. Another great opportunity at South, and this is also available at North and Central, is the RST program. That stands for Ready, Set, Transfer. The RST program is a great scholarship program funded by the National Science Foundation. They gave each campus $1 million to give out as scholarships. So we've been giving out about 20 to 30 scholarships a quarter for up to $2,500. I would say most of our students, depending on financial need, actually receive that full amount. It's one of the best scholarships on campus, and it will help fund a little bit more than just tuition. It might even help you with transportation or other costs of going to school. So that's fantastic. You also get paired with a STEM mentor, faculty mentor that will help you connect and transfer to other programs. It also provides a little bit of money for undergraduate research. And then the cool thing about it is it's a scholarship that just keeps renewing until you transfer. So you can receive it, and it can help fund even after some other scholarship opportunities have dried up. So it's a really fantastic scholarship opportunity for our STEM students, especially our engineering students. One more option at South, if you want more community, is to join the STEM Corps. STEM Corps is a great support network for those students that are studying engineering. There's paid internship opportunities available at NASA or the national labs. The national labs are great. That would be a great thing to put on a resume, getting that sort of internship. It connects you with our student support specialist, who's a full-time support staff to help you, guide you through sticky academic situations and help you navigate transfer and the internship process, and she's just fantastic. So definitely check that out if you're planning on coming to South. All right, so what are some advantages of taking engineering transfer classes specifically at South? The big thing is we have small classes. Most of our classes are less than 15. Besides just myself, we also have Farhad, who's also got engineering experience with real world design experience. He comes from the mechanical engineering side of things. He used to do some jobs for NASA. So lots of cool real world design experience in your instructors. Our course catalog will help prep you for most of those sophomore classes that you need. So when you transfer, all you have is 2 years of 2 years of college after transfer, which is really fantastic. So we have the specialized courses that you need for mechanical, aerospace, civil, environmental engineering, and then also electrical engineering. A lot of our classrooms, all of our engineering classrooms, and most of our science classrooms are based around the active learning model. That means you're doing less sitting and getting talked to, and more doing things, which is really research shows is better for learning. It helps a lot of students who have challenging that have or challenged paying attention in class. I personally have ADHD, so I understand this active learning model is really helpful for me too, and it's fantastic. We also have a lot of hands-on capstone projects that are kind of part of our engineering program here at South. I want to show you some of those right now. For instance, here's our engineering CAD course. This is CAD and CNC plasma together. So the cool part is you're not just learning the CAD portion, you're also learning how to use CNC technology. And CNC plasma is a very specific case of CNC CNC technology. But that CNC technology is also used for machining, and used for lathes. It's used for additive manufacturing. So once you understand the CNC manufacturing process, you can really apply it to a lot of different fields. I would say a lot of engineering design is looking more to the idea of design for manufacturing. You are working very closely with a CNC technologist to build these things in-house. So that's kind of a really useful skill for our engineering students. Here's a short little clip of one of our students. A lot of our students, this is a class that's taken by both our engineering class students and our welders, so we get a lot of cool overlap. This is kind of one of the videos made by one of our welders. Can everybody see the video? Give me a thumbs up. Awesome. So there's a preview of what it looks like, and here's the CNC plasma in action. This is sped up a little bit here. It's probably about double speed there for the cut. And that's what it looks like after a little bit of polish. Specifically, that's a flap disc, but you can get an idea of the sort of the things that you can create using CNC plasma. For our 200 level engineering courses, this is an example project of our truss analysis projects. I'm actually working on this right now with some students. This is some pictures from a previous class. So students will build a truss bridge using our structural model, and then we will measure these internal forces using these sensor packages. And then using the analysis practices that we've been working in class, we'll do hand calculations and also compare it to some computer output and get an idea of how good are the things that we're learning, how effective are the assumptions that we are making. So this is a kind of a cool way of seeing, does this actually work in real life? In our dynamics course, this is our 215. This is a little bit more of an involved project. You have some more experience. So you actually create a physical model of one of the concepts that we practice in class. Sometimes students will pick a particular problem from the homework or a particular topic that's challenging, and they build a model. So this is one of the ones from a previous quarter. This is them working on it. They built a microcontroller with a stepper motor driver to drive the system. I'll show you the animation that they created. They created this based on a kind of an ornithopter design And you can see here's the laser cut parts that they designed and cut on our laser cutter in the makerspace to create their final project. And once they finish, I'll need to get some pictures of that and video of that in motion. So here are some quotes from actual engineering students at South. These are some things that students have said about it. Everybody wants to be in class and learn. It's a very positive place to be in. Students really, class sizes were huge. Our class sizes at my old school were somewhere between 50 and 300 students, depending on the class. Our class sizes are around 15 max. Seeing examples in class has really helped me succeed. Most of the class is practice problems and questions, and it's not just lectures. And I really enjoyed the project-based learning. All right, a little bit about our pathway at South. Most of our engineering students need 9 quarters to get the courses that they need for transfer. We have what we call a major related program. It's a little bit different than an associate's degree, but it kind of fits that same niche. So you take 9 quarters, that's 3 years. That gets you so our program looks like a 3 + 2. You do 3 years here, and then you transfer, and you finish your final 2 years after you transfer. The really nice thing about it is it's kind of a built-in cohort model, so you work with a lot of the same students in a lot of your classes. So you get to, because you have a lot of overlap in terms of transfer prerequisites and then the classes that you have to take in order. So you'll get to know your fellow students really well, and that'll be a great support group for you as you deal with some of the more challenging math and science courses that you're going to be taking. This 3 + 2 program will prepare you for a lot of most engineering design jobs, which is really cool. All right, so some entry requirements. For most students, I tell them, hey, as soon as you can, take that Intro to Engineering course. At South, we offer that in the fall, and we offer that in the spring. To get into that Intro to Engineering course, all you need is a placement into Math 98 and a placement in English 101. After a year or 2 of math and science courses, after you take Physics 221, you can sign up for Engineering 214 and start that Engineering 200 level sequence. That's your sophomore level engineering courses. Those are kind of the 2 levels of entry. I would say for most students, I really suggest taking that Engineering 110. That will help you figure out what sort of things you want to study, how to succeed in all the math and science courses that you're going to take, and kind of get you a good grounding in the professional skills that you'll need to be a professional engineer. All right, let's talk a little bit about jobs, right? First up is civil and environmental engineering. That's my major. The median wage for a civil or environmental engineer in Seattle is about $93,000 a year. Some of the industries that they work in, if you're in the environmental engineering side, you'll be doing a lot of environmental impact studies. That's looking at the effects of new building or new construction on the environment. Or also, civil engineers work in transportation, so road design, infrastructure, transportation, bus routes, train routes. Those are all transportation engineering. We also have civil engineers that work in drainage design. Where does the water go? How does it drain out of our parking lots, off of our buildings, get collected safely? How do we treat our wastewater and water that we drink? And then my background, which was structural design of buildings and bridges. These are all industries that civil and environmental engineers work in. For those mechanical or aerospace, we'll get to aerospace in a sec here. There's a lot of overlap. medium wage for mechanical engineers, about $104,000 a year in around the Seattle area. One of the big ones is HVAC. A lot of students don't realize that heating, ventilation, and AC is huge, right? How we heat and cool our buildings is huge. So HVAC engineers are in short supply. Working in aerospace, I would say most mechanical engineers or most engineers working at Boeing or in Boeing related fields or vendors actually have degrees in mechanical engineering because that's like a good portion of this of their workforce. You can work in controls is another option. Those are people that are designing the hydraulics that run all of our heavy manufacturing and construction. And of course, the really, really exciting mechanical engineering job of vehicle design. Electrical engineering is our third big one. Our median wage for electrical engineers is a little bit higher. I think there's a lot of overlap with the tech field with the electrical engineers. Big industries that they work in is power systems, working for the power grid. How do we distribute power? How do we generate power and store it? How do we design the electrical part of our controls, right? Mechanical engineers have controls. Electrical, we're starting to see more and more of those controls go over to electrical as the devices get cheaper and safer. And then also related to that, robotics and manufacturing, right? Robotics and manufacturing in the US go hand in hand, and all the stuff gets driven by electrical sensors and electrical motors and solenoids, etc. All right. That is all I have for our engineering talk, but I wanted to open it up for questions. What questions do we have about engineering education? Questions about our programs here at South and classes. I'd love to answer any questions that you have. You feel free to unmute yourself, or you can throw your questions in the chat. Happy to answer any questions that you have.
Hey, Albert, I had a question.
Yeah.
So you mentioned, I might have gotten a little confused. Did you say that, I guess, with Seattle colleges, the typical course length for somebody maybe going for like electrical engineering would be like 3 years at Seattle colleges before transferring to another 2-year school?
Yeah, so for depending on your major and what your background is, I would say for a lot of students it looks like a 3+2. I think electrical engineering is a little bit of a asterisk there because they often don't have to take the mechanics series, the 214, 215, 225. So for some electrical engineers, it can be a 2-year program, but it kind of depends on what your background is. A lot of so for this one would means you complete it in 2 years after transfer. So you use 3 years before you transfer, and then 2 years to complete your degree after you transfer to your UW Seattle or Bothell or Tacoma. You complete that after the fact.
Gotcha. Thank you.
Yeah. What other questions can I answer for y'all?
Albert, is there still any kind of preferred pathway from Washington community colleges into UW Seattle? I know that used to be a thing, but a
preferred pathway. I don't know if the preferred pathway. I don't know if there's a preferred pathway, like anything in legalese writing per se. I will say that we do have, direct transfer agreements. So like, that's one of the nice things about doing the MRP program is a lot of students are like, well, if I take 3 years of credit, will it transfer? And the answer is yes, right? We have the MRP is a transfer agreement. So when you get accepted into any university or 4-year system, you're going to other 4-year system, you will all of the classes that you need to get to graduate in 2 years will transfer, which is really great. So you don't have to spend a lot of time going back and taking, classes that are, a lot of our engineering students end up taking like a lot of their liberal arts requirements here at South, and then they're able to, just really focus in on their junior and senior year on the classes that they need.
Gotcha. Yeah, I think back in the day, if I remember right, it was if you maintained at least, I think it was like a 3.0 GPA, you had automatic admission into the University of Washington, but I think they got rid of that.
Yeah,
Yeah.
I haven't heard about that, so I think that may be an old program.
Gotcha. Okay, thank you.
Yeah. Yeah, the transfer into specifically UW Seattle has recently changed a lot of the way that they admit students into their engineering programs. It used to be that like kind of everybody had to, after their sophomore year, even if you were a UW Seattle student, you basically had to apply to the engineering school as if you were like a transfer student. So it kind of put our transfer students and their students on a similar level, but they kind of moved away that to a direct admissions thing. So they're not doing it that way anymore. So a lot of the ways that they admit our students has changed a little bit. So that's one of the cool things about South Seattle College, and especially if you're interested in transfer, doing the RST program is you get paired with a mentor that can help you walk you through that process. So you're not facing that alone. There's a lot of complexity in that, and we have a lot of resources to help make sure that you're taking the classes that you need for transfer, and looking at all the options available, because we have a lot of great schools in the area without even leaving Seattle.
Gotcha. Okay.
All right. Sharing the slides. I think the slides will be available. They're going to make them all available through the Discovering College website, but if you want to email me at albert.engel@seattlecolleges.edu, I'll make sure you get a copy of the slides. I'm going to put up some typical questions here that I expect if you don't have any burning questions about, but just so you have these in front of you. Any other questions I can answer?
Hey, Albert, I know you mentioned that intro to engineering class, but I was wondering if there are any other resources you would recommend for students who are kind of unsure of what engineering area they want to go in.
Ooh, good question. So I think there's kind of two pieces of advice I have for that. So one thing is to go check out our program's website. So South Seattle College has some blurbs about what those things look like if you go to our website. Bear with me with my tabs and everything, but if you go to South Seattle College and you navigate over to our programs menu, you can kind of look at our programs. And if you get into like civil and environmental engineering, it'll give you a little bit more information about those things. So that's one way to do that. And it also shows you our program maps, so you can learn more about some career opportunities and things like that. I'll link that here in the chat. This is specifically civil environmental engineering, but there's links to other programs there. The other big thing that I suggest students who are like interested, or if you have like multiple options and you kind of narrowed it, like I don't know if I want to do mechanical or I want to do civil, which of these is a better fit for me, or I'm trying to figure out if I want to do mechanical or aerospace. One great thing to look into is doing informational interviews. That's where you kind of reach out to somebody that or just cold call somebody that like, hey, you're working at a company I want to work at. I would love to go buy coffee with you and like pick your brain about what your job is like. It's also a really great way. Sometimes those informational interviews turn into internship interviews. You'll end up getting an internship opportunity or connected to somebody who's looking for an intern that way. So that's a great opportunity for you to kind of explore those. Is, you know, ask somebody who does the job already. We love, as engineers, we love to talk about the cool stuff that we do. Um,
Yeah, for sure. Thank you very much.
yeah. What other questions do we have?
Do you know roughly how many classes are in person versus online or through Zoom room?
Yeah. Do you have questions about like the balance? It's kind of specifically, I can speak specifically for engineering. Some of our STEM classes and math, every department's a little bit different right now because we're transitioning back to more face to face. For our engineering classes, all of our classes are face to face hybrid right now. So we're about half time face to face and half time asynchronous learning. We kind of do like a flipped classroom model. So um, we don't spend as much time of me talking at you, telling you the thing, but also giving you resources and some recordings to help you learn it. And then we practice those skills in a active learning environment. I would say a good portion of our that's engineering. A lot of our uh, science courses are kind of that face-to-face hybrid model. And I would say I think more of our math courses are moving more face to face. That's kind of the thing. So I would say that probably about at this point, I would say a good uh, 80 to 90% of your classes are going to be face to face or face to face hybrid, and then maybe 10% is going to be online. There are some options, but that's been the kind of big push. Lots of students have been asking, hey, we want more face to face, like give us that face to face again. But we do have some more online opportunities, especially for those, you know, things in the humanities. For sure, we're seeing more and more, you know, offerings for English and history and all those other, you know, really important contextual classes that help you communicate and be a good engineer.
Thank you.
All right. Thank you, everybody. Hopefully see you at South soon.